All right. Well, good morning, AP Statistics students. Some of you, this may be the first time seeing me in a while. I know during the AP review time that for those of you not taking the exam, you were able to focus on your other classes. And I am so sorry about the messages about simple incompletes that came out. There was a lot of confusion around that. The school board's policy, the way we had to notify people was if they hadn't been on the tracker, they got notified. And for some of you, you weren't on the tracker because you weren't doing AP. So that is not your fault. That is a fault of the system, the one that the school board adopted. And yeah, I'm really sorry about that. I hope it didn't cause too much anxiety for you and your family at home. Today, what I'd like to do is just talk to you really quickly about comparing two means. This is section 10.2. I know that we have a couple of assignments from 10.2 this week, and then some chapter 10 review stuff next week, and then the optional chapter 10 tests for everybody. I know it's after the seniors' last day, which is Friday the 5th, but they're able to turn stuff in until the 12th. And so that's what those two little assessments are going to be about. One's about 10.1, one's about 10.2. And again, given the policy that the school board has adopted, unless you were failing before, then you're going to be just fine if you're doing the assignments and submitting them and watching these videos. And if you can come to class on Friday, that'd be great. Quick word on Friday, I may be a tad late coming over. I have another Zoom meeting at 10. It's a district thing, so not a class, but I'll get there as close to 10:30 as I can. So please be patient, and I'll see you guys as soon as I can on Friday. I'm looking forward to seeing you guys. So we are going to talk about comparing two means. Here we go. So here we are, comparing two means. Previously, before we were left for the break here for COVID-19, we talked about comparing two proportions. I did put a note sheet in your folder on comparing two means. And then recently, thanks to one of our students who was very adamant that I include that, we put in one about two proportions. And so much like the two proportions ones, we're comparing two groups now. So population 1, which has a mean, which we'll call mu1, and then population 2, which has a mean, which we'll call mu2, which always means, our two friends have to make their appearance. Here's Mew, the Pokemon Mew. We could call that mu1 if you want. And then, of course, Mewtwo has to make his appearance here today, too. So those are the two Pokemon. One of them shares the name of the mean for the second group. So, all right. This is our objective for our lesson here. I'm not going to run through all of the slides because, well, as you already know, the font doesn't copy over very well. So there's already empty boxes and things like that. So we'll skip over some of those as we go through. The main thing I want to get to here are the procedures for how we compare two means. And so we can do so in a significance test or confidence interval for the difference of the two means. So let's get right to it. The parameters of interest, there they are, mu1 and mu2 again. The best approach, of course, is the two independent random samples from each population. And, it could be an experiment. It could be just two different populations, like residents of Washington State who wear masks everywhere they go versus residents of our neighbor, Idaho, who wear masks wherever they go, something like that. And you could look at the average number of people in a store wearing masks. You probably actually do it with proportions, but we could do it with means as well. And this is basically what we want to get to, is that population 1 is going to have a mean mu1, and we're going to not know that, or we're just going to be using our statistic to approximate that because we want to estimate the difference, or we want to see if there's a significance difference. And so based on our sample statistics. So they don't have to be the same size samples, of course, so you can have two populations, sample sizes, N1 and N2 from each population. And that's really the bulk of the work, is to come up with these statistics and to see what that tells us about our parameters. So here's where, unfortunately, we have some boxes. So we're not gonna spend a lot of time on this slide. Obviously, you know that the center of a distribution for X bar, mu for X bar, is just mu for the entire population. So the center of your sampling distribution for sample means is, because it's an unbiased estimator, is mu. The standard deviation for that distribution of X bar, that's a good one to remind you, though. So I will write that one in. You know, this is, I'm gonna write it down here. Sigma for X bar is, of course, equal to sigma for the entire population over the square root of n. So that's a good reminder that once you start putting them in groups, we see that standard deviations shrink, and it shrinks by a factor of 1 over the square root of n. And so just like with the pennies that we did earlier this year, we saw how the larger groups, we had smaller standard deviations. So that's a good reminder, though, because it has been a little while for some of us since we got to do this stuff. So this is an example for the heights of boys and girls. This is showing that the heights of oh, wait a minute, that's right. These are not adults. These are younger. So they're looking at, you know, for girls, the distribution is this first one, A. You can see the center is equal to the population mean. But our spread is the population standard deviation divided by the square root of 12. And then for the boys, the center is the population mean. And the spread is, of course, the standard deviation over the square root of 8, because there's 8 in the sample. And then finally, if you want to find the mean, that's easy. You just subtract the two subtract the two means. The reminder here is to find the standard deviation. Remember, you cannot just subtract these two. In fact, you don't subtract. What you do is you find the variances and you add them, and then square root at the end. So that's a good reminder, and that's coming up here in a minute. Oh boy, check out all the boxes here that don't have the numbers in them. We'll write this stuff out. It's actually in your notes sheet too. So here's what I really wanted you to see. Now we actually have the characters in here. So the sampling distribution of x1 bar minus x2 bar is hopefully going to follow this nice normal curve. The center of it will be mu1 minus mu2, which is this green line right here. And here's that standard deviation equation I want to remind you all. It doesn't matter that we're subtracting x1 bar minus x2 bar. We still take the variances. See, here's sigma 1 squared. Here's sigma 2 squared. Take the variances over their respective sample size and add them. Really important to add them, because the variances are positive because you square the coefficients. All right. Okay, and this is annoying because of all the missing characters and stuff. So we're just gonna flip through this. And I'm just going to jump to this one to remind you that if you don't know sigma 1 and sigma 2, if those aren't given, you can still do the process. You're just going to use a t statistic instead, and you're going to use S1 and S2. So this should be plus right here. So that's the standard error in the statistic x1 minus x2. And so there we go. You square the sample standard deviations and divide by them. The normal condition doesn't have to be met again. Remember, T procedures are robust, so you can just use your t procedures. And your t statistic down here equals x1 minus x2 bar minus mu1 minus mu2 s1 squared s2 squared n1 n2. And that's how you come up with your t statistic if you're going to use t procedures instead. All right, clear those. All right. Oh boy, the trouble with t procedures, and this is where it gets a little bit different, is this is a confidence interval here. When you are looking for a t statistic, right, you have to know degrees of freedom. Well, in the case of a single mean, when we did it before in chapter 9, that was easy because there was only one sample size. But now there's 2 sample sizes, and how we come up with the degrees of freedom, it's still n minus 1. It's just whichever one is smaller. If it's n1, then you use n1 minus 1. If it's n2, you use n2 minus 1. If you do this on a calculator, you're actually going to get a different value for your t statistic, and your degrees of freedom will be different. There's a procedure in your calculator where you can use t interval or a 2-sample t significance test, and it will compute a different degrees of freedom using something called Satterwhite's approximation. Satterwhite was a mathematician who worked in statistics, obviously, and he had a formula for how to do this. And I have Satterwhite's formula here for you. I would suggest to never ever do Satterwhite's formula because, let's see, can I switch over to the camera? Satterwhite's formula is really complicated. Let's see, is it showing? I don't think so. Now it's, I can't, I have such a tiny little video screen here. I can't tell if you guys can see that very well. I hit the autofocus button. That's Satterwhite's formula for approximating degrees of freedom. And it's really not necessary, guys. Don't even worry about it. Unless you do with your calculator, you won't ever actually need to use that formula. But since I know some of you will probably be curious, I thought I should show that to you. So that's the formula that your calculator will use to come up with its own degrees of freedom. All right. Well, what I'd like to do is actually work through the computations with you here. So this is probably where the video is going to break. So that's a little bit of intro. This is actually going to be working through a problem. We're going to use this data right here. And we're going to do a 90% confidence interval. And then we're going to do we'll do a significance test to show kind of how these all work. So this is where the video is going to break.